How can we address the issue of read delays when using a one primary multi-standby database architecture? How do we maintain strong consistency? Hello and welcome to another episode of Cloud Forward. Today we'll show you how we can increase the overall throughput capacity of a cluster in order to solve the problem of delayed reads from standby nodes. The read-only node provides eventual read consistency by default in a one primary multi-standby database architecture. Although physical replication and shared storage technologies can significantly reduce latency of read-only nodes, they cannot guarantee that read requests sent to the read-only node get the latest data written on the primary node. As a result, delayed reading from the read-only nodes can cause inconsistency issues, especially for business in the industries that are sensitive to data latency. Let's take a look at how PolarDB addresses the issue. What we did is to make use of existing network infrastructure resources and integrate RDMA technology to introduce the High Performance Strict Consistency Cluster, SCC. SCC ensures that any primary and read-only node in the cluster can provide strong consistency of read after write, while also effectively reducing the load on primary nodes through read-only triage of strong consistency read requests. In an OLTP scenario, it significantly improves the overall throughput capacity of a cluster. Now, how is the SCC feature technically implemented? We call it PolarTrans. It employs CTS technology, commit timestamp store. It replaces the traditional active transaction list to manage transaction. PolarTrans uses CTS and RDMA network to provide strict read consistency for read-only nodes at the kernel layer, ensuring that the most recent data from primary and read-only nodes is always visible, thereby providing strong consistency read capability among the cluster. When PolarDB's PolarTrans feature is enabled, each read and write request on the primary node is assigned a timestamp when it is committed. This can be either a logical timestamp or a hybrid logical timestamp tied to a physical time. Simultaneously, the primary node logs the transaction ID and commit timestamp CSN into the redo log. Then the read-only node reconstructs the entire transaction state by replaying the redo log. In a SCC architecture, the read-only node obtains the most recent commit timestamp from the primary node via RDMA one-side remote read, which is then used to calculate current transaction latency, build strictly consistent read views, and so on. SCC is implemented with a large number of concurrency optimizations, and the query results between multiple threads can be reused, reducing the number of remote reads and overhead, and keeping the time consumption for transaction status synchronization to be less than 2% of the time taken for a strongly consistent read. If you're looking for products that address read consistency, check out Strict Consistency Cluster, feature of PolarDB, by clicking the link in the description below. Don't forget to subscribe to this channel for more Cloud Forward videos in the future. Until next time.